Today, we are going to discuss the minimum variance portfolio.
The fundamental idea behind this portfolio is to minimize the variance. Therefore, the only parameter considered here is the variance. And we are not considering maximizing the individual returns of each stock that is included or considered to be a part of the portfolio. So the portfolio objective will then look something like this. We are going to minimize the overall portfolio variance. W here represents the width, T is the transpose, and sigma is the variance covariance matrix.
That gives us the portfolio variance.
In order to solve this particular equation, the major operation required is to find the inverse matrix, or alternatively, the variance covariance matrix. So, for example, if we assume that the variance of the first asset is 4%, the second asset's variance is 5%, and there is a positive correlation that specifically amounts to 3%, then we would have the variance and the covariance matrix.
The initial step when you're looking to determine the inverse is to first calculate the determinant, and then you proceed by carefully shifting the positions of the elements and subsequently reversing the sign of each of the other elements. Once you've successfully found the inverse, the result that we obtain is this.
Matrix.
The inverse matrix is essentially the matrix we're searching for, the one that, when multiplied by our initial matrix, results in the identity matrix. This identity matrix is often represented by I, and it's characterized by having ones along its main diagonal and zeros everywhere else. It's quite similar to the concept of multiplying any number by its reciprocal or its inverse,
which will provide a single one.
Now, once we've successfully determined the inverse of our matrix, we can then proceed to calculate the z value. This z value is obtained quite simply by taking that inverted matrix and multiplying it with the column vector of 1. The notation bold 1 that you see here specifically indicates that we are referring to the column vector where all its elements are 1s.
The z value, as we're discussing it here, directly corresponds to the overall width. Therefore, to accurately determine this width, our first step is to sum the two relevant numbers, and subsequently we calculate the individual proportion of each of those numbers relative to that total sum. This calculation will then provide us with a specific width measurement for our initial asset, and similarly, we can then determine the corresponding width for the second asset in question.
Once we determine the appropriate width, we then proceed to multiply it to calculate the overall variance of the portfolio. For instance, if you take the initial variance covariance matrix and multiply it by this calculated width, you will effectively derive the precise variance of our entire portfolio. So, the variance of our current portfolio stands at 3%. More precisely, it's 3.66%. This represents the absolute lowest variance that we are able to achieve, and we can construct this optimal portfolio by allocating 66.6% of our funds into the first asset, with the remaining portion then going into the second asset. So now that we've discussed the theory, let's put this concept into practice by navigating to the Finance Research Gate website. First, I'll need to locate and access the specific section of the website that contains the data we'll be working with. Once there, I'll adjust the data parameters, specifically selecting a monthly frequency for our analysis, and then carefully define both the starting and ending years for our data range. For our initial data series, to keep things manageable and focused, I will carefully select just a single stock for our examination.
And of course, the primary input that we are aiming to minimize in this particular scenario is the monthly return. For this specific analysis, I'm going to select just one stock from the entire series of available options. Following that, we will then proceed to apply the necessary filter. Now, for the second series, we are going to be selecting a completely different firm. And let's take, for example, a very well-known and prominent company, Apple, and apply. So we selected asset 1 and asset 2. Now, in the third series, we're going to create the minimum variance portfolio. Your task is to carefully select the initial asset and then subsequently choose the second asset before you can proceed to apply. Necessary filters. Through this process, we are effectively determining the average value. This, however, is merely the very first foundational step. Our primary focus and concern at this point is the construction of the portfolio itself, which means we will be fully utilizing the dedicated portfolio section specifically for Series C.
So our goal is to find the objective of minimum variance. For the covariance estimator, we can use the sample. We had a separate video discussing the distinction between the sample and the Deadwood-Wolf shrinkage estimator. We are going to use a 12-month period to find this parameter. This parameter is the variance-covariance matrix. It includes the variance of individual assets and the covariance between the assets. We will use data from every 12 months to determine the parameter and subsequently calculate the width of the minimum variance portfolio. We will then rebalance the portfolio every single month. So as soon as a new month begins, we will recalculate the widths and identify the new minimum variance portfolio. Essentially, we are determining the minimum variance portfolio using a rolling window approach. Here, we can simply remove any limitations or constraints from this particular condition that we've been considering. What this essentially means is that we should allow the portfolio to hold any weight, regardless of its size, that the minimum variance strategy ultimately dictates for us. So for the purposes of this specific scenario, we will make the decision to select a high value. If you prefer to avoid a high concentration of weight in any single investment, then you have the option to set a minimum number of assets, thereby establishing a clear upper limit for the proportion of your capital that can be allocated to any particular asset class or individual investment. However, in this specific scenario, we need to ensure that it remains completely unconstrained, allowing the portfolio's objective to operate with maximum flexibility and freedom. Here, we don't need to make any modifications given that we possess only two distinct assets, and then we can proceed to run the portfolio. So we need to go back and choose the Series C again because it seems we overlooked some crucial details earlier. Okay, that sounds like a perfectly reasonable plan. So here we are returning to this point in our discussion, and it's probably a good idea to keep this particular setting or option activated for now.
And oversee the management of the investment portfolio.
So we have successfully obtained the results from our analysis. These figures represent the optimal allocation or weights that we should invest across the two different firms. Consequently, on a monthly basis, we will be constructing a brand new portfolio designed to minimize variance. And as is quite evident from these results, the most effective solution primarily involved allocating exactly 50% of our capital into each respective portfolio. It's crucial to keep in mind that these figures are presented as rounded numbers. Therefore, we might not observe an exact 50% split. This is because after the rounding process, each individual firm is represented as 0.5. If you scroll down, we can then easily make a direct comparison between them.
When we analyze the individual stocks and also the minimum variance portfolio, it's a fundamental expectation that the MVP will consistently show a much lower variance in its overall performance when directly compared to the individual investments themselves. So in this situation,
if you take a moment to carefully compare the performance of this specific investment portfolio, we will notice that its calculated standard deviation stands at precisely 11.6%. However, for both portfolios A and B, their respective values are considerably higher than this figure. So, we successfully managed to minimize the overall variance. This is, of course, if we include only two stocks within our analysis. However, if we were to incorporate a greater number of stocks, then it's quite possible we would achieve an even greater degree of risk reduction. This is simply because we would then possess a wider array of assets within our investment universe. And that concludes our discussion on the minimum variance portfolio. Thank you very much for watching.